We now discuss how to find the optimal decision when we have the probability information of the state of the nature. Oftentimes, we can receive probability information about the likelihood of the occurrence. For example, we can get those information from the historical data. We can also ask the opinions from those domain experts. Or we can interview people such as marketing research to obtain some information about the market. In this case, we continue to have the four decisions, A, and B, and none. And we have two possibilities of the state of the nature. If the airport is going to build at location A with a probability of 0.4, or airport is going to build a location with a probability of 0.6. Different from the decision rules without the probability information, currently, we do have the probability information of 40% for location A and 60% for location B. So how to find the optimal strategy based on the probability information? We have one rule we call expected monetary value. In expected monetary value, we are going to find the expected value of the payoff given that the probability information we have. For example, in this equation, ENVI means expected monetary value of decision I will be equal to the sum of the payoff Ij times Pj. Pj is the probability of state of nature J. So we are going to sum up all those Uij times Pj for every state of the nature. Uij means the payoff of decision I in state of the nature J. So basically, ENVI is the average payoffs given that the probability information for every state of the nature. Let us look at this example again. We have decision A, and B, and none. We have airport built in location A and B with a probability of 0.4 and 0.6 respectively. For decision A, we have two utilities, 13 million and negative 12 million for location A and B respectively. To compute for the expected monetary value, we have ENV I equal to A is equal to the sum of Uij times Pj. For J equal to A, we have 13 times 0.4. And for J equal to B, we have negative 12 times 0.6. We sum these two items together, we get negative 2 for the ENV I equal to A. In other words, the expected monetary value if the decision is A is equal to negative $2 million. So we have even B for A equal to negative 2. For the rest of the decisions, we have 3.4 for decision B, 1.4 for A and B, and 0 for none. Now we are going to pick the highest value among the ENV for every decision. Obviously, we are going to pick the decision B equal to $3.4 million because it gives us the highest profit. We can use the same approaches for the expected opportunity loss, or we call it expected regret. The EOLI denotes the expected opportunity loss of decision I will be equal to the sum of Rij times Pj. Rij is the regret level of decision I in state of nature J, and Pj is the probability of state of nature J. Coming back to the regret table we have already done previously, we have this regret table 0 for decision A in state of nature A and $23 million for decision A in location B. Following the equation of the expected opportunity loss for decision I equal to A, we have 0 times 0.4. 0 is the payoff for decision A if airport will be built in location A, and 0.4 is the probability for location A, plus 23 times 0.6. 23 is the decision A, location B's payoff. We have 0.6, which is the probability of location B. Sum these two items up, we get 13.8 expected regret or expected opportunity loss for decision A. We do the computation for the rest of the decision. So we have expected opportunity loss 8.4 for decision B, 10.4 for decision A and B, 11.8 for decision none. Different from the expected monetary value, we are going to find the minimum value among these four EOL values. So obviously, 8.4 is the minimum expected regret. Actually, if we compare the optimal decision from the expected opportunity loss and the expected monetary value, we find that they have the same optimal decision. And actually, this will happen all the time. In other words, the decision with the largest EMV will also have the smallest EOL. We can mathematically prove that because the regret is defined as the optimal of the payoff minus the payoff UIZ. And actually, for any decision, for example, decision A, we have EOL decision A plus EMV of decision A will be equal to a constant value. So when we have the highest value of EOL, we are going to have the lowest value of EMV, or we are going to have the highest value of EMV. At the same time, we get the lowest value of EOL. So we always have the same optimal decision, no matter whether you use EMV approach or use expected opportunity loss. Thank you.